Welcome to Lesson 5, problem number 1, where we are solving literal equations. Literally, what that means is that there's more than one variable in an equation, and we have to isolate one of those variables. In this case, the variable we're going to isolate is x. So let's get started. In 1a, we're going to start by trying to get x alone. So we are going to take t. So we're going to do minus t. Let me write that a little bit nicer for you. We're going to say minus t from both sides. If we do it to the left, we have to do it to the right, and then it's gone. So now we simply have kx equals r minus t, and all we need to do now is to get x alone, and since k is multiplying the x, we can just divide by k. So technically there's two ways you can write your answer. The k's are now canceled, so you could either say simply that x equals r minus t over k, or if you prefer, you could write it as x equals r over k, sorry, that's an r, minus t over k. And either answer is equally good. Okay, let's look at B. All right, once again, we're trying to get x by itself. So let me kind of start off. Let's distribute that k through there to start. So we're going to do kx plus bk equals f. All right, so now we're trying to get x alone, so we're going to just say kx equals f minus bk. We're subtracting bk from both sides. I didn't show that step, but I think after the first one where I showed the minus t's, you'll see that. Now we're just going to divide both sides by k. So x is equal to, and this time I'm just going to leave it as one fraction, but you know you could write it as two separate fractions. And we just simply have x equals f minus bk all over k. Done. Okay, let's look at C. For C, we're again trying to get x alone. So I'm going to start by subtracting the b. This time I'm going to show the work. So we have r minus b equals x over k. And the b's are gone on the right-hand side. Now we're trying to get x alone, so I am going to think of all of this, r minus b over 1, and I'm basically going to think of it as cross-multiplying. So I'm just going to take another color so you can see. When we cross-multiply, we basically get x times 1, so x equals k times the quantity r minus b, and we're done. Okay, let's look at D. D is a light bulb. It's a really challenging problem, but let's do it. All right, so the first thing that I think we should do is let's move that 1 over y to the right-hand side. So we now have 1 over x, and I'm again not going to show the step on this light bulb, but it's 1 over z minus 1 over y, because we basically have subtracted 1 over y from both sides. So now, there's a couple ways we could do it. We could just now multiply everything through if we wanted to, so that we could kind of get rid of the zy, but I'm kind of thinking what I would like to do is get a common denominator right here. So right now I have 1 over x equals, and to get a common denominator, I'm going to just change our color. I'm basically going to multiply this fraction by y over y, which is a fancy version of 1. I'm just multiplying by 1. Same thing here, I'm multiplying by z over z, which is just a fancy version of 1, which we can do. We're not changing the value. So our new fraction on the right-hand side is going to be y over zy minus z over zy. Sorry, my y's are a little different there. But now we have a common denominator, so now we can simply say 1 over x equals y minus z over, let's make it yz instead of zy. It just sounds a little nicer to me. That time I put a little dash in there so you know it's not 2y, it's yz. And what we know is that if 1 over x is equal to y minus z over yz, what we know is we can say that x over 1, or the reciprocal, x is equal to the reciprocal of that fraction. And we're done.